Next speaker is Krisciunas. He's going to talk about to what extent are type 1a supernova standard candles in the near infrared.
Good morning. Question. Don't be shy. How many people feel kind of brain dead? Come on. Yeah, okay. Yes, we had a 3-day meeting before this 5-day meeting. Okay, so I'll sing you a song. Give me a supernova, a bright one in the nighttime sky. Something like -7th magnitude, I beg you, don't be shy. Zap me with your neutrinos, produce a little lead and gold. Give me a bright new star at night before I'm wrinkled, gray, and cold. Bum, bum, bum. So, I was thinking the other day, that's the core collapse supernova song. Okay, I was thinking that we haven't talked too much about the fact that there hasn't been a bright supernova in the Milky Way since 1604. We are long overdue, right? And so, contemplate the fact that Betelgeuse will eventually become a supernova, right? But there's a problem there. If it goes off in June, the only place that you can see it under nighttime conditions is at Dome A in Antarctica, okay? Because you need the sun below the horizon, you need the supernova above the horizon, but even at Dome A, Betelgeuse is 2.2 degrees above the horizon. And in June, when Betelgeuse is between 16 and 24 degrees from the sun, even there it's in twilight. And so we need a satellite to take the fast observations as soon as Betelgeuse goes off, if it goes off in June. So there's a future problem for observing. But let's talk about type 1a supernovae. Let me show you a few infrared light curves. You want to get them close to maximum light. And data were pretty scarce for a long time. This is a good set from Bob Kirshner's paper of 1973. Here's supernova 1972e. They took spectra, they used filters, they made photometry, and they got a pretty good K-band light curve there at 2.2 microns. And the next two really good infrared light curves were 86G, and two research groups got good data on 1998 BU. I would assert that 98 BU was the sort of the beginning of optical and infrared data for type 1a supernova. We struggled mightily before that, not we, other people. But things really got going about 1999. Of course, there were the Harvard people like Sarab headed up that wonderful paper on 98 BU. When I looked at it, I said, wow, who's this young postdoc or assistant professor? No, he's just a grad student. I thought, wow, this is really good paper. And Sarab became the man we know and love that we have today, okay? At CTIO in Las Campanas, thanks to Mario and Mark and Nick, there was a lot of data taken then, and I got in the act also the same year at the University of Washington when Chris Stubbs and Jean Monnier and Al Dirksen and I started taking optical and infrared data. But things really got going in 1999. So here's something very simple. Another thing that you can get from light curves, you can figure out the time at which objects peak in the infrared with respect to a B-band maximum. Some of them are early and some of them are late. It's very, very normal that a type 1a supernova peaks in the infrared maybe 3 or 4 days before blue band maximum, okay? But there seems to be this dichotomy that the ones that peak in the near infrared after blue band maximum are subluminous in all bands, including the infrared. But those that peak in the infrared prior to B-band maximum, they are subluminous in optical bands, of the fast decliners that is, but those objects that peak early are only slightly subluminous in the infrared bands. And so, the very simple thing I'm talking about today is to what extent type 1a supernovae are standard candles or still standardizable candles in the near infrared. So if we throw out those late peaking fast decliners and the occasional superchandra object and fit a line, you get a slope that's slightly different than zero, as Gaston found in his 2010 paper and Cheyenne Kapner found with CSP data. But there's one little thing that you should fold into this, and that is that each of those points has an uncertainty in x and y, and so why not use some function to give you some random number of standard deviations from a Gaussian distribution and move those points around and try it 100 times or 1,000 times. Here we are for 100 times. So in the J band, with that subset of blue points, the slope is non-zero, but only at the 1 sigma level. In the K band, it's the same kind of thing. So if you're going to do the very best cosmology with type 1a supernovae and you want to use the fast decliners, then if you know they peak early, then you can use this slight decline rate relation to do your best cosmology. You don't find very many fast decliners in high redshift surveys, because if you observe them, let's say in rest frame V, they might be up to 10 times fainter, the fast decliners compared to the slow decliners, and so you have a volume that's 1,000 times less. So we find very few fast decliners in the high redshift surveys. So you want more data than I showed in those plots. CSP1 is almost ready to be sent to the journal. We have all the finder charts, we have all the number, the magnitudes for the field stars, we have all the photometry reduced, we think we know the reduction parameters, and if you want to make a full print out, it's 375 pages at the moment. So that's coming to a preprint server near you very soon. And then there's CSP2, so we'll have more. So the H band seems to be the best filter to use because the slope of the slight decline rate relation is the shallowest, and maybe type 1a supernovae really are essentially the standard candles in the near infrared. That's the sweet spot, and you can hear more of that by Kara Ponder this afternoon in her talk. The only problem with the H band is that of telluric absorption. So here's the state of the art of Hubble diagrams in the near infrared. This is rest frame H band, a paper that is on the preprint server but hasn't been revised and published in the journal yet. This is Valery Stanishev. It goes out to redshift 0.18. And we tried with the VLT to get some rest frame J band photometry of objects at redshift 0.35, but it's just not a very good use of 8 to 10 meter class telescope time. So you're fighting against the sky. You can maybe get 2 points in a night. So in order to push the Hubble diagram out to higher and higher redshift, you really need to get outside the atmosphere. So we'll just have to wait for JWST and W first. That's all about all I wanted to say. Thank you very much.
Thank you, Kevin. You're also known as
Yes, one of my nicknames at Las Campanas is El Mudo, the guy who doesn't talk.
You've been shorter than your time, so. Are there questions for Nick?
Do we have 2 minutes? Okay. There are 88 keys in a regular piano keyboard. There are 88 constellations in the sky. And this is how you can remember them. The constellations in the sky were not put there to bore us. There's Antlia, Andromeda, Aquarius, and Taurus, and Apis, Leo, Lepus, Aries, and Centaurus, Carina, Crater, Cancer, Canis, Major, Minor, Corvus, and Aquila, Orija, Leo, Minor, and Monoceros, Columba, Libra, Lyra, Lynx, and Coelum, Cygnus, Cercimus, Corona, Borealis, Cetus, Crux, so do not scorn us. When you learn, we fondly love the likes of Capricornus. Horologium and Hydra, Hydrosindus, Microscopium, and Cepheus, Bookis, Eridanus, Telescopium, Chameleon and Hercules, Durago, Draco, Delphinus, and Norma, Octans, Lupus, Musca, Pixus, Crus, and Scorpius. There's Coma, Berenices, Fornax, Pavo, Puppus, Perseus, Corona, Australis, Buchanan, places like Aquilius, Sagittarius and Sagitta, both north and south, Triangulum, and Sputum, Sculptor, Sexton, Serpens, Mensa, and Reticulum, Lacerta, Ophiuchus, Pictor, Gemini, and Pisces. Is where we hope to find a cloud of interstellar ices. Orion, Piscis, Austrinus, and Phoenix, and in Pegasus is where the clouds are dense enough and each then coalesces. Towards Cassiopeia, towards the giraffe, and also towards the hunting dogs. We find the stars and galaxies and scribble in our nightly logs. Ursa Major, Minor, Vela, Virgo, Volans, and Vulpecula is where we plan to aim tonight with $1 million specula. To lofty mountains off we go in confident reliance, in hot pursuit of photons there and world-beating science.
That should have been in the cultural session, but next speaker is Mario